here comes law number 4 in this section, and that is a to power ab to power x divided by cb to power y is equal to a over b times b raised to power x minus y. Let us see a proof. Let this a be 6, and let this b be this 2, let this x be 5, and let y be 3. So we have 6 times 2 to the power 5 divided by 3 times 2 to the power 3. Let us get the answer to this by carrying out traditional operation on these numbers, meaning convert this to ordinary form and convert this to ordinary form, divide this by this, and let's get the answer. Let us do it. 6 times 2 to the power 5 means 6 times 2 times 2 times 2 times 2 times 2. 2 appears 5 times here. That is the power 5, then times 6. So this is given as this when expanded. Likewise, this is given as this when expanded. It therefore means that we have to get the result of this multiplication, and the answer is 192. And also get the result of this multiplication, and the result is 24. So 24 dividing 192 will give us this 8. Now let's evaluate the same number operation, but this time around applying associative law. Please watch out as I apply associative law in carrying out this number operation. Notice that this number operation is the same thing here. Let's now use associative law to carry out that number operation. This divided by this is something as saying 6 times 2 to the power 5 over 3 times 2 to the power 3. Associatively, this can divide any of these two, while this can divide any of these two. But preferably, let index divide index, and let a non-index divide a non-index. That takes us to 3 dividing 6, see it here, and then 2 to the power 3 dividing 2 to the power 5, see it here happening. I hope you know what empowers us to separate this into these two operations. Again, it is associative law, which we are supposed to have learned earlier in a topic known as arithmetic laws, that we're supposed to apply here to be able to arrive at this point. So far, if you apply it, this becomes this. Let's make progress. That means that when this 3 divides this 6, we can still write as 6 over 3, though we know that the answer is equal to 2. For a reason, let it remain 6 over 3. Then what about 2 to the power 5 divided by this 2 to the power 3? That will be evaluated using the law of division, the first law under this section. That will be 2 to the power 5 divided by 2 to the power 3. That will give us 2 to the power 5 minus 3. Please, 5 minus 3 will give us 2. That means that what we have here is 2 to the power 2. When 3 divides this 6, the answer is 2. So out of this bracket, we make 2, and then times out of all the things here that we make, which is 2, the answer is equal to 8. That is 2 from this bracket, 2 to the power 2 from this expression. 2 to the power 2 is 4, then 2 that we get out of this bracket times the 4 we get from this expression will give us this 8. That means that so far we have used 2 methods. The first method is a very plain method, traditional method, which is division of an ordinary number by ordinary number. That is, a number in its ordinary form divided by a number in its ordinary form. And second process for the same operation highlights the importance of adopting associative law in divisions of this kind. In both cases, the answer is the same, 8 here, 8 here. Let us make a kind of deduction from this second line of action. Let us observe that this, which is same thing as this, is equal to one of these results. This is a result, this is also a result, this is also a result, and this is a result. I want to equate this expression to this, giving rise to 6 times 2 to the power 5 divided by 3 times 2 to the power 3 is equal to this, which is 6/3 times 2 to the power 5 minus 3. Since this will give us 8, the same 8 we got here, we can conclude that, not minding what is here, whether it is 6 or something else, whether it is 2 or something else, whether it is 5 or something else, whether it is 3 or something else, the conclusion is that A times B to the power x divided by C times B to the power y is equal to A over C, then times B raised to the power x minus y. Let us see some examples of number operations that conform to this law. And here are the examples. The first one says 12x to the power 5 divided by 3x to the power 2. Obviously, when this divides 12, the answer is 4 based on this law. And then we now have x to the power something 5 minus 2 based on a law we have learned earlier, and the whole thing is equal to 4x to the power 3. Example number 2 is 3y to the power 3 divided by 3y. We should know by now that though there is nothing written here, there is a power of 1 above this y. That means that y1 is here. When 3 divides 3, see it here, it is equal to 1. So 1 is what comes out of this bracket. Next is y to the power something. 1 times y to the power something. That something is going to be 3 minus 1 here, based on a law we have learned earlier. And 3 minus 1 is 2. Therefore, 1 times y to the power 2 is y to the power 2. Example C goes this way. This is k divided by 4k to the power 2. Before we proceed, let us recall that this k is the same thing as k to the power 1 divided by 4k to the power 2. Again, recall that there is something here unwritten. It has a coefficient of 1 but not written. But in practice, we're going to include it. That means that 1 is here. So when 4 divides 1, it will give us this 1 over 4. Then based on this law, k is common, bring it out here. It will be, because we have this sign of division, we evaluate by saying this minus this. That will give us this 1 minus 2. 1 minus 2 is minus 1. Therefore, we have 1 over 2, which is still here. Then times k raised to the power minus 1. I hope you are following what is going on here. Now let's continue. If you simplify this further, what you get is this k to the power minus 1 over 4. A number of factors, a number of points, things that we have known before will lead us to making a conclusion that this is equal to what you have here. At this point, please try and check if you understood the point that is being made in this section. And here comes the checkpoint. It says evaluate the following operations, recalling that a b to the power x divided by c to the power c b to the power y is equal to a over c times b raised to the power x minus y. The first is 15y to the power 4 divided by 3y to the power 2. Number 2, that's number b, is 3x to the power minus 4 divided by 9x. The third one is a y to the power 5 divided by g y to the power minus 1. The last one, and that's number d, is 4m to the power minus 1 divided by m raised to the power minus 5. Now we look forward to the fifth law under this law of division and derivatives.